All right, here's more of simplifying radicals, and we're going to, I think there's about 8 more problems to go. So first we're going to do some factoring here. 32 is 2 times 2, right? That would be, well, let me start with 4, and let's say 4 times 8, 2 times 2, 8's 2 times 2 times 2. And then we're going to put this under the radical. Okay, so I want these in groups of 4 because my index is 4. So 2 to the 4th times 2. And then on the a to the 11th, I need that to be an exponent divisible by 4. So that's going to be a to the 8th times a to the 3rd. Now remember, 8 plus 3 is 11, so that goes back to rules of exponents when I'm multiplying. That's why I can split this any way I need to. In this case, I needed the one exponent to be divisible by 4, and I needed that to be the biggest possibility. And then whatever's left over will be my other exponent. So I'm able to take this root and this, and that would be, all right, 2 to the 4th would be 2. A to the 8th would be a squared, right? Because I'm going to take 4 into 8, which gives me 2. And then the 4th root of 2a to the 3rd. All right. So negative 64. Negatives are okay when my index is odd because that's still a real number. All right, so let's factor. So 64 is 2 times 2 when you're talking about 32, right? So 64 has a bunch of 2s. So let's just look at this. If this was, say, negative 8 times 8, so that's going to be 2s, right? How do I want to do this? I'm just going to keep the negative on the outside and do these 2. So it's 2 times 2 times 2 times 2 times 2 times 2. And so I have 2 to the 6th power. Now I'm going to write this as negative 2 to the 5th power times 2. So that's negative 32 times 2, which is negative 64. Because that root has to be a negative because of how it was written in the first place. All right, so now under the radical, I will have the 5th root of negative 2 to the 5th times 2. On the x to the 6th, we're going to split that as x to the 5th times x to the 1st, right? When I add those, I get 6. And y to the 10th times y to the 3rd. So as long as I can write it as an exponent divisible by my index, I'm going to be able to find that root. So when I take these, right, this comes out, this, and this. All right, so that will be negative 2x y squared. The part that stays under the radical is 2x y cubed. Notice each of those has an exponent that is less than 5, and it has to be less than 5 to be simplified completely. Okay, so here's the next 2 questions. On the first one with the 18, we're going to factor the 18, which is 2 times 9. So that's 2 times 3 times 3, right? 2 times 9, and then I break that down further. Now this one happens to be a square root, which is 3 squared times 2. And then we have x to the 4th times x to the 1st, y to the 6th times y to the 1st. When it's a square root, the part that we have left over will always be to the 1st power, as we're just splitting those with the highest even exponent, and then the leftover part's always to the 1st power. We can take these roots, so that will be 3x squared y cubed, And then we will leave the 2xy underneath, right? They'll stay in the radical, the roots come out, and then we're finished on that. All right, the next one, 75. Oh, let me factor it first. I'm still used to the way I used to do this. I'm trying it a different way. So 3 times 25 is 3 times 5 times 5. And then on the b, we're going to just split that up as 14 and 1, right, on the exponent. So this is going to be 5 squared times 3, b to the 14th times b to the 1st. I can bring out the even exponents. There's a root for those. So that's going to be negative 5b to the 7th times the square root of 3b. And then that's completed. All right, here's the next one. So we start out by factoring 40, and 40 is 5 times 8. And so the 8's 2 times 2 times 2. We've used 8 a lot in this lesson. So 5 times 2 times 2 times 2. All right, so now we can write this in the radical. So 2 to the 3rd times 5. And then on the y to the 10th, to split this as an exponent divisible by 3, that's y to the 9th times y to the 1st. I can take the cube root of 2 cubed and y to the 9th. So that's 2y cubed times the cube root of 5y. Okay. So this next one, negative 243, negative 243 is a perfect 5th power. And if I factor 243, it's going to be, I'm going to do this thing again with the negatives. It's 3 times 3 times 3 and so on. Let me go ahead and write that. So that is going to be 3 times 81. I'll say a negative 3. And then that's 3 times 81's 9 times 9. So 3 times 3 times 3 times 3. We've got a lot of 3's. Okay. Now I'm going to make all of those 3's negative because the root will be a negative 3. Okay, so negative 3 to the 5th power. And so I have a 5 that matches my index of 5. On the z, we're going to split it as z to the 5th times z to the 4th. Because 5's the highest exponent there, I can bring these two out, right? I can find the roots of these two. So my root will be negative 3z times the 5th root of z to the 4th power. All right. Next. Okay. So on this next one on 12, I'm going to go with this a little bit different. So I'm going to show it this way. 12 is 4 times 3, right? 4 is a perfect square, and I can find the square root of that. And then that will be r to the 8th times r to the 1st and s to the 12th, because 12 is an even number. I can take the square root of 4, r to the 8th, and s to the 12th. So I have 2 r to the 4th, s to the 6th, times the square root of 3r. Okay. Now 162 is possibly going to be one that you wouldn't recognize so much. But 162, I'm going to show this on this one too, is 81 times 2. And then I have x to the 4th times x to the 3rd. And y to the 20th because 20 is divisible by 4. So I can take the 4th root of 81, x to the 4th, and y to the 20th. So 81 is 3 to the 4th power. So this will be 3x y to the 5th times the 4th root of 2x cubed, right? The 2x cubed stays because we can't take a root of that. And then this is the answer. All right, so we're finished with this lesson, and that's it. Bye.